In this lesson, we're going to finish up talking about 1- and 2-step equations. So the first thing we're going to talk about is how to clear fractions. So what I mean by clearing fractions is if I had something such as 2/3 x minus 7/3 equals 1/3. Now, this problem isn't too difficult to solve if I have a calculator or if I'm really good with fractions. But whenever you're working with fractions or decimals, you're more likely to make a silly mistake just because of the numbers. So what we can do is we can actually eliminate those fractions and make the numbers much easier to look at. So to clear fractions in an equation, you're going to multiply every term on both sides of the equation by the least common denominator. So what I mean by that is when we're looking at this equation over here, if we look at these lower numbers, the 3's on the bottom, the denominators, we can actually find our least common denominator for this problem. And in this case, because they're all the same, it's simply 3. So what we're going to do is we're going to multiply every single term. So there's 3 terms here, 2/3 x, 7/3, and 1/3. We're going to multiply every single term by 3. So now that we've done that, you're going to see that when we multiply this 3 times this 2/3, these 3's in effect cancel out because 3 times 2/3 is simply 2x. Same thing over here when we do 3 times 7/3. The 3's cancel out and we're left with minus 7. And then over here, 3 times 1/3 is going to be simply 1. And this is nice because now 2x minus 7 equals 1 is a fairly simple problem, and all our numbers are now integers, so we have in fact cleared the decimals, sorry, the fractions. So we're going to add 7 to both sides now. So here we get 2x plus 0, or just 2x, equals 8. And then we're going to take and divide both sides by 2. So x equals 4. And of course you could check this using a calculator, and you should check it just to make sure. But when we check this, it does in fact work. So now let's look at number 2. We're going to have 4/3 x minus 1/2 equals 3. Now again, not a too difficult problem, but we do have several fractions here that might be a little bit easier if we didn't have to deal with them. So we're going to find our least common denominator. So again, we have to look at our denominators, our bottom numbers. So we have a 3, we have a 2. Now, we also have a number under this 3. And if you recall, it's an understood 1. So this is really 3 over 1. So when we're looking at 3, 2, and 1, we're looking for the very smallest number that everything can go into. So it's the least common number. They all can be multiplied to make them into that number. So, for example, I can't change a 2 into a 3. However, I could multiply 2 high enough and I can make it a 6, which 3 can also become a 6. So what I mean by that is if I was to start counting, if I started counting 3, 6, 9, 12, and so on, and if I did 2, 4, 6, 8, and so on, and then 1, 2, 3, 4, 5, 6, and so on, notice that the number they have in common, the smallest number they have in common, is a 6, which means my least common denominator is going to be a 6. If I multiply every single fraction by 6, there will be no more fractions to work with. So that's what we're going to do. So we're going to have 6 times 4/3 x minus 6 times 1/2. And this is going to equal, let's get rid of all this stuff here, this is going to equal 6 times 3. We can put the 3 over 1. So now, notice now the 6 and the 3 don't cancel completely, but I can say 3 goes into 6 twice, so 2 times 4 is 8x. Okay, so what's happening here is we're still eliminating the fraction on the bottom, but there's still a leftover on the 6 because 6 and 3 Again, the 3 goes away and this becomes a 2 because 3 goes into 6 2 times. Here, 2 goes into 6 3 times, so we'd have 3 times 1, which is minus 3. Then over here, we don't really have to worry about the 1 here. We just do 6 times 3, which is 18. Now again, this is a much easier problem to work with because all we have to do now is add 3 to both sides. So 8x equals 21. Again, this is 0. And then divide by 8. So x equals, now if you try to divide this, 21 over 8 becomes a decimal. And typically if we start with fractions, we end with fractions. So in this case, we want to end with a fraction. Now 21 and 8 have no common factors, which means 21 over 8 is the least reduced problem. So that's going to be the smallest fraction we can have. You could write this as a mixed number, but you can always write this as an improper fraction, and that's perfectly fine. And this would actually be easier to check back in the original problem. So if I were you, if you have a graphing calculator, go ahead and check this and see if it works. And you will find that it actually does. Okay, again, we don't want this as a decimal because we started with fractions. All right, so let's look at number 3. We have 7/4 minus x equals 1/8. So we're looking at our least common denominator, which means we have to look at our bottom numbers. Now even the x has a denominator. Remember, it is an understood 1. So when we're trying to find our least common denominator, we have to think through, okay, if we have 4, 8, 12, 16, 20, and so on. 8, 16, 24, and so on. So if you'll notice, they have an 8 in common, but these numbers also have a 16 in common. But we're looking for the least common denominator, the least common factor here. And in this case, the least common factor is 8. It's smaller than 16. So we're going to take and multiply everything by 8. Okay, so over here on our problem, we're going to take and do 8 times 7/4 minus 8 times x over 1. Now we don't have to put it over 1, but if it helps you, you can. And that's going to equal 8 times 1/8. You have to multiply every single term by 8. So now here we have 8 times 7/4. So notice the 8 and the 4. 4 goes into 8 twice. So we're left with 14. Here we just have minus 8x, and that equals, and these 8's are going to cancel out, so that equals 1. So now we have this little bit simpler problem. So the first thing we're going to remember is that there's an understood number in front of the 14. It is a positive. Therefore, we are going to subtract 14 from both sides. This now equals 0. We have negative 8x equals negative 13. So now we're going to divide everything by negative 8, giving us x equals, now a negative divided by a negative is a positive, and then 13 over 8 is not going to simplify anymore. So since we began with fractions, we're going to end with fractions. So 13 over 8 would be our final answer. So let's look now at number 4. We have 3/4 x minus 1 equals 2. Now, this is one that we wouldn't necessarily have to clear fractions on because there's only one fraction, and we could actually just multiply by the reciprocal when it comes time to it. But we can get rid of the fraction, especially if you're not one that likes to use the reciprocal. So looking here, we're looking at the denominators once again. So this one has a 4. This guy and this guy both have an understood 1. So our least common denominator between 4 and 1 is simply going to be a 4. So we're going to do 4 times 3/4 x minus 4 times 1, and that's going to equal 4 times 2. So here, these 4's cancel, and we're left with a 3x. 4 times 1 is negative 4, and 4 times 2 is 8. So now we're going to solve our two-step equation. Add 4 to both sides. 3x. this becomes a 0 equals 12, and then divide by 3. So here x equals 4, which is an integer. You do not have to put this over 1. Okay, it's okay for an answer to be an integer. The only time we leave it in a fraction form is if it's not an integer answer. Okay, so let's try number 5. 4 over 21 minus 7/3 x equals 3 over 7. So I want you to go ahead and pause the video at this point and try this problem. When you're ready, turn the video back on. Alright, so at this point, if you're ready for the answer, I'm going to show it to you right now. So number 5's answer is going to be negative 5 over 49. So if you got this one right, go ahead and give yourself a little smiley face over here so we can know that you got it right. If you got it wrong, give yourself a little frowny face. That means we need to look at this one again. So your least common denominator should have been 21. So hopefully you multiplied every single term by 21. Now I will tell you, one step that has a common error is this one right here. Okay, students get lazy and they don't want to write this divide by negative 49. And so what happens is they end up writing the wrong answer, which is negative 49 over 5. So negative 49 over 5 is not the same as negative 5 over 49. It's actually quite different. So please, 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 just write this one little extra step. It takes 2 extra seconds. 2 extra seconds is the difference between getting an answer correct and getting it wrong.